Okay, we have power on this time.
We copy. Thanks.
And for step 2, SSC 112 is already up. It's the one I've been using. Do I need to close everything else down, or are you guys just going to take control of it?
And we'll take control of the SSC. Don't close anything down, please.
And we have his arms stretched out. He's kind of like the patient in physical therapy who's been in a cast. We need to start going through range of motion.
And we copy, and we'll have some more ground commanding for you and give you a call back for step 9.
So far, everything looks really great. Going through the pre-planned maneuvers. The sound of the motion is even. It sounds smooth with no abnormal noises.
Once the left arm is completed its damping, we'd like for you to press with the right arm damping.
Okay, copy that. That's step 2.
That's a good copy. Thanks.
Okay, and I've completed the vision test already. Step 3 is complete.
Woohoo! Thank you.
And the reason is this command didn't kick off the first time I attempted it, and so I went ahead and during the LOS I went ahead and did step 3. I saw we still had a long time to go, so I reattempted this one and it kicked off. Not sure what happened the first time.
And copy that. And Mike, can we get confirmation that you received good vision at and that the cameras were in focus?
That is affirmative.
Awesome. Thank you.
Okay, slow arm twist. Okay, into the stow location.
Station Huntsville on 2 for Mike. Once the left arm is completed its damping, we'd like for you to press with the right arm damping.
Okay, copy that. And that's step 2.
That's a good copy. Thanks.
And I've completed the vision test already. Step 3 is complete.
Woohoo! Thank you.
I just wanted to say congratulations to the team. I know they've been working on this for years, and it was, today was first motion, and this is a big step that they've, dreamed of getting to for a long time, and it's really huge. It looked really, it looked great from here. Have a small bit of binding with the cloth in his sleeves at the elbow. Hey, who hadn't felt that before? I'm sure they'll figure out how to find the right stowed location for him. It's an exciting day for the Robonaut team, and congratulations.
Thanks for those kind words, and the PD team appreciates them.
So checkout 1.5 is what we accomplished yesterday, and it was a very exciting day for our lab in particular, all the flight controllers that we had on the ground watching the robot and the crew. I don't know if you got a chance to see Mike Fossum in some of the video, but he was a very excited individual running that robot, and then we were equally excited watching him run that robot. You can sort of already get the sense of the relationship that the crew and Robonaut could have in the future. You could tell that Mike felt very like the activities that we were doing with Robonaut represented this new age that we're trying to usher in, which is having the crew and a highly dexterous humanoid work together. And we were just so genuinely excited to see his enthusiasm. And the events couldn't have gone any better. Having the first humanoid robot aboard the ISS move under its own power was really a momentous day. And we had all of the flight controllers. It was really tough to contain our emotion because you're supposed to be this stoic, have this sense of seriousness in the control center, but yet we were grinning from ear to ear like kids in a candy store, just having the most wonderful time watching the accomplishments that were being shown or being done before us, and it was quite exciting. So our checkout yesterday was looking at how the robot needs to, the differences between how the robot's going to work in 0G and how we've been testing it on the Earth in 1G. And specifically, the robot was going through and moving its arms one by one, moving each of the joints in its arms to understand the differences between operating in 1G and 0G. And so we have these, the robot's actions are controlled by a set of software parameters. And those software parameters have to be adjusted between here on Earth and in the space station. And so we had the robot go through and adaptively learn the differences between those software parameters. There's quite a certain choreography to it of how we interact with the crew, because we don't talk directly to the crew, and how we have to discuss. We have our Robonaut flight controllers, and they discuss the actions and what's going to take place and any off nominals that we might have with specific actions. And so those have to get sent up to the crew. And then the crew and their observations are sending down to the flight controllers on the ground what they're observing. And so there's this nice little dance that has to occur. And plus we're doing commanding both from the ground and on board the station. So with yesterday's events, for example, Mike Fossum was actually commanding the robot on the station. And so he was initiating the scripts, and he was loading the scripts that were having the robot run through and like I mentioned, adaptively learn its gain parameters for operation. But at the end, we had the ground stow the robot. And so there's this nice trade-off and this dance that has to occur back and forth, and a lot of real-time ops that are happening in coordination. So anytime we have a checkout on orbit, there's a lot of products that go into that. We have the training products that we have to create. We have crew come over and get trained up on the robot. They dry run the procedures. We also have a lot of real-time ops products that have to be created. There's an entire flight ops community that we're interfacing with, and everybody has to be brought up to speed on what's going to happen, what's to be expected, how much time is going to occur, and so all that has to be that all has to be coordinated ahead of time, so that when things are happening real time, everything's expected in terms of what the robot's going to do, what its next actions are. Everybody's on the same page, and so it takes an amazing amount of time and preparation in order to achieve that level of understanding between the ops community. Then there's the technical side to it, what we're trying to accomplish on the robot from a scientific point of view. And so all that has to be married together, because we have our milestones as researchers in the lab, and the ops community has standards in which they need to achieve those milestones. And so we're trying to bridge those two worlds together on this unique payload such as Robonaut. So this milestone for checkout 1 and 1.5 was particularly important because it was the first time the robot moved under its own power. The previous checkouts that we had done really looked at just booting up the robot systems, making sure that everything from a sensor point of view, from a computer point of view, had survived ascent to the space station as we expected it. So we powered up the computer systems, we looked at the thermal signatures, and because we wanted to take things slow, and we've become very satisfied with the state of the robot. And so checkout 1.5 was, okay, let's get that robot to move and go through the adaptive learning script to tune the software parameters on how it moves in zero-G. So that was a huge gauntlet that we had to go through, because we're not flying a fancy computer. We're flying a robot to assist the crew with their daily activities and on the activities in particular that we feel the robot could better serve. You know, cleaning things and assisting the crew from that point of view. So we ultimately have to get the robot to move, and so this was a huge milestone, because it means that all the systems, and there are hundreds of systems that are all cross-checking each other, sensors that are cross-checking each other, that have to work in order for the robot to even begin motion. Robonaut 2 was developed in partnership with General Motors, and the technologies coming out of Robonaut are, one, helping General Motors on the manufacturing line, and two, helping NASA with its pursuit of space exploration, and in particular human space exploration with cooperation with robotics.